Good day, ladies and gentlemen. We are looking at one more problem on tree diagrams. It says a certain game involves tossing a coin followed by rolling a dice. Represent the information on a tree diagram, then calculate the following probabilities. Calculate the probability of obtaining a head and a one, a head and an even number, a head and a prime number. A head cannot be a prime number again. I guess this one should be an odd number. So again, that's a very simple exercise. So we know that this game involves tossing a coin followed by rolling a die. So a coin has only two options, a head and a tail. A die has six. So that means in my tree diagram, the first part of it, which is for a coin, should be having two options. These are my two options for the coin. Let's say this is the coin. Then I've got the probability of a head. Since there are only two options, we get 1 out of 2. Then the probability of a tail is also 1 out of 2. And when we add up the two probabilities, leaving a point, that must give us 1. That's the story. Now, the second part of the game says we must roll a die. Since it's 1, we call it a die. But the die has 6 options, so we must get 6 branches, leaving a point. So that's 1, 2, 3, 4, 5, 6. The same thing here. 1, 2, 3, 4, 5, 6. So we must get something like that. So the probability of the 1 will be 1 over 6, 1 over 6, sorry. The probability of the 2 will be 1 over 6, the probability of the 3 will be 1 over 6, the probability of the 4 will be 1 over 6, and the probability of the 5 will be 1 over 6, and that of the 6 itself will be 1 over 6. So that is it. We must get all the 6 options. Then we'll go to this other point. We'll get the probability of the 1 is 1 over 6, the probability of the 2 is 1 over 6, the probability of the 3 will be 1 over 6, the probability of the 4 will be 1 over 6, so 1 over 6, not 1 over 4, the probability of the 5 is 1 over 6, and finally the probability of the 6 is also 1 over 6. So as we all know, with the tree diagram, if we've got 6 branches, leaving a point, and if we add up all the probabilities, we must get 1. The same thing here, if we add up all the probabilities, we must get 1. So that's the nature of our tree diagram when we toss a coin followed by rolling a die, or the opposite way, we'll always have something like that. So let's now go to B, Roman 1. We need the probability of a head and a 1. So it's straightforward. A head and a 1. You see the option is straightforward. You start reading from the beginning to the end. So get a head and a 1. So if I need the probability of a head and 1, it means I'm just taking a half times 1 over 6, which is 1 over 12. So that's how simple it is. I will also say a tail and 1, or a head and 2, a head and 3, a tail and 5, and so on. So you just start from the beginning, you follow the right branches to the end, just like that. So that's how simple it is. Roman 2, we need a head and an even number. A head and even number. So this is where it becomes a bit interesting because there are 3 even numbers between 1 to 6. There is a 2, a 4, and a 6. So a head and an even number means you get a head and 2, or a head and 4, or a head and 6. So that's it. So to get a head and an even number, we get the probability of a head and 1, or sorry, a head and 2, or a head and 4, or a head and a 6. So those are the options. So if we need a head and 2 will be 1 over 2 times 1 over 6 plus 1 over 2 again times 1 over 6 for a head and a 4. So that is a head 2, a head and a 4, a head and a 6. So that is it, 1 over 2 times 1 over 6. So that gives us 1 over 12 plus 1 over 12 plus 1 over 12. And that should give us 3 over 12. So that's how we get a head and an even number. So the same thing goes with a head and a prime number. So all you need to do is just know what is an even number, what is a prime number, and so on. So a head and a prime number. So what do we do? The prime numbers are 2, 3, and 5. So you must know your prime numbers. 2, 3, 5. So I'll get a head and a 2, or a head and a 3, or a head and a 5. So that is it. I get the property of a head 2, or you see each time I use or, I put addition. One other things you must know, or goes with addition and goes with multiplication. So I get a head and a 2, or a head and a 3, or a head and a 5. So it is basically giving us the same things we've got up there, because a head is 1 over 2, a 2 is 1 over 6, so we get 1 over 2 times 1 over 6, plus 1 over 2 times 1 over 6 again, plus 1 over 2 times 1 over 6. So that should also get us to 3 over 12. So it's basically the same story when we need a head and an odd number. So this is actually a simple exercise. So the odd numbers are 1, 3, 5. Those are the odd numbers between 1 to 6. We've got 1, 3, 5. So that means we get the property of a head and a 1, or a head and a 3, or a head and a 5. So that is it. So a head is 1 over 2, a 1 is 1 over 6, plus 1 over 2 times 1 over 6, for a head and a 3, plus 1 over 2 times 1 over 6, for a head and a 5, and that should also give us 3 over 12, which is the same thing as 1 over 4. So guys, that is how easy it is. But I think we can also get some interesting ones, because here we are told to get the probability. We are told that we are tossing a coin followed by rolling a die. So what if the probability said calculate the probability of a 4? So you have to always start from the beginning till you get to a 4. Or if it's a 5, you start from the beginning till you get to a 5. So let's say we need the probability of a 4, for example. So we toss a coin followed by rolling a die. So if I need the probability of a 4 as my 5, the probability of a 4, don't forget that you can't get the 4 just like that. You must toss the coin first before you go to the die. So if you know how you read probabilities on your tree diagram, you always start from the beginning to the end. So to get a 4, it's either you get a head and a 4, or you get a tail and a 4. That is the way it is. A head first and a 4, or a tail and a 4. So that is how I get it. I'll get a head and a 4, or a tail and a 4. So if you know how we read probabilities on a tree diagram, starting from the beginning to the end, anything they ask from you, you just want to start from the beginning until you end where you are going. So a head is 1 over 2, and a 4, which is 1 over 6, or a tail is 1 over 2, and a 4 is 1 over 6. So that gives us 1 over 12 plus another 1 over 12. So that leads us to 2 over 12, or 1 over 6. So guys, I guess that looks easy. And what we've done, you can do it the same thing with the tail. A tail and a 1, a tail and an even number, a tail and a prime number, a tail and an odd number. Then you can look for a 5, 6, a 1, up to 1, 2, 3, 4, 5, and 6. You can calculate them knowing that you read from the beginning right to the end. So that is how simple it is. That was just to show to you how do you read probabilities on the tree diagram from the beginning to the end all the times. So guys, I guess that is enough on that. Thank you very much.